Hello, welcome back to another episode on large language model. So far, we have learned about how we can encode text, tokenization of the text, then how we create token embedding on this text, followed by positional encoding, and then we create combined embedding. But today's video is extremely important because we are diving into the heart of LLM inside transformer architecture, and we are going to discuss about attention mechanism. We are going to talk about how query, key, and values together build the attention mechanism which helps LLM to understand or make a meaning of the context. There won't be any code. There won't be any mathematics in this video. It will be pure understanding through analogy. So let's get started.
Here we have 5 different sentences. She plays the piano well. The lead role she plays brilliantly. He plays cricket with great skill. Under tension, the rope plays freely. In silence, she plays her part. So if you notice, all this sentence has plays as one common word. Their positions are different, but most interestingly, all of them have different meaning in each of these sentences. So at this stage, we have plays with some static token embedding, which we have gone through in previous video. We have also positional encoding information available, which is based on their position in these sentences. But all this sentence has different meaning for plays. If you notice, the first sentence, plays means performs music. In the second one, it's about acting. Third one, it talks about playing cricket as a game. Fourth one is about moving of ropes. And the fifth one is about fulfilling a role or duty. So all of them have distinctly different meaning, even though the static token embedding will give you the same vector representation. If you notice, there is close connection or relationship with some of the words in these sentences. We pay attention or focus to those words to derive the meaning. Here is just one sentence, but it can be a long paragraph or some reference in previous sentences if we are reading a book or a long document, or maybe some information which was there previously that need to be related to understand the meaning of particular word. Now, before we start, let's take a quick look at a legendary paper called Attention is All You Need. It is written by Ashish Vaswani and collaborators from Google Brain and University of Toronto. This was released in 2017, and this is the paper that introduced transformers and revolutionized AI. Before this, models relied on clunky step-by-step processing, but the author had a radical idea: what if we just use attention and nothing else? It doesn't require any convolutions, no recurrent neural network, just pure attention to connect words dynamically. This is the overall transformer architecture. We'll go through it later. Result of this 9-page paper was phenomenal. Faster training, better long-range understanding, and birth of models like GPT and BERT. This paper changed AI forever, and today we are still building on its ideas. So at this stage, we are going to focus or put our attention to this transformer attention concept. If you look at the architecture of transformer, this is what transformer architecture look like. It has got 2 distinct parts in it. Left side is called encoder and the right part is decoder. Model like BERT use encoder, while all the LLM use decoder. We'll go in detail about this architecture in upcoming lesson. At a high level, if we put our focus on attention and we are focusing on LLM, so we'll put our focus mainly on this masked multi-head attention. This multi-head attention has many scaled dot product attention combined together or stacked together, having different heads. So our focus will be on individual dot product attention, which is also called self attention. Once we understand this self attention, multi-head attention is just an extension of this single head attention by incorporating many parallel head running simultaneously. It's basically trying to capture different aspect of context in parallel. Now the question is, what are these Q, K and V? These are the main building blocks of transformer architecture. Q stands for query, K stands for key, and V stands for value. So query represents what we are searching for, like a search query. K represents potential matches, like keys on documents in a database, and value holds the actual information we want to retrieve. So if you notice, there is a glaring resemblance with the concept of database, and you are not wrong. This query, key and value concept was borrowed from standard database, like a relational database, where we write query to extract values based on keys. Refer to this SQL example for query, where we are selecting values from a database. Here you can think entire internet as a database, and the key here is place. So if you are coming from database world, it's very easy to visualize how this query, key and value are structured. But what are these query, key and value from transformer point of view? The query, key and value are basically projection matrix. So there will be some interaction with input data, and these projection matrices will be generated through training process. But these are not parameters. Rather, we have weight matrix for which we will be training. Can you guess what would be the training process? How we will train these weight matrices? Yes, it's back propagation. All this deep learning based AI technology predominantly using backpropagation as their engine to train these models. We'll go through this architecture and how the mathematics plays its role while deriving this attention mechanism in upcoming videos. But before that, I think it's extremely important to understand how this query, key and values works from a real world analogy. Let me try here with one analogy, and I'm sure after that you will never forget attention mechanism. But for that you need to pay a little bit attention. For this analogy, I'll be using the third sentence. He plays cricket with great skill. So those who are not familiar with cricket, cricket is a very popular game. In fact, if you search the internet, you will find with more than 2 billion people following the game. So now, imagine you are in a huge library filled with books on different topics, sports, history, science, and many, many more things. You go to the librarian and ask, I need books that explain how someone plays cricket. So here, your request represents the query, trying to understand the meaning of place in the context of cricket. The librarian checks the book catalog and finds tags. So these tags are like keys based on the tags that relate to your request. So these are the keys, the catalog on books. They help determine whether a book is relevant to your query or your request or it is not. Here are the 6 books that librarian has initially sorted out. It's about cricket technique, the history of cricket, mastering sports skill, theatre performances, batting techniques of Sachin and Virat, learn piano in 10 days. Now, the actual content inside these books represents the value. So if you can notice, the cricket techniques is about how to play cricket, mastering sports skill, general playing skills, partially relevant as it has got some information about cricket. And the third book, batting techniques of Sachin and Virat, how to master advanced technique in cricket, but it's focusing on one small part of cricket, or I would say small, but one important part of cricket, which is batting. We have seen in library context what is query, what is key, and what is value. Now let's understand, using the same analogy, how transformer attention would work as a step-by-step process. So first thing is, there will be comparison of query with each key, and system checks how well book tags keys match with your request query. The librarian assigns something called similarity score in transformer or attention language. Here, the cricket techniques, it's like about 90% match because it's highly relevant. Mastering sports skill, somewhere in between because it's partially relevant. So you can say it's 50% match from similarity score point of view. And the third book, betting techniques on Sachin and Virat, it's like about 70% match. It talks about techniques but only focusing on betting part of it. Rest of the books, those are ignored because they are not relevant to cricket. Now, once we have the similarity score, next will be to assigning attention weights. So more relevant books will get higher weight and less relevant books like general sports will get a lower weight. And cricket book on betting get somewhere in between. So with this information, librarian hands over the best book on playing cricket to you. And in this case, it will be the cricket techniques. Now, if I convert this entire steps from transformer point of view, the word plays in the sentence, trying to understand its meaning. So here, query is place. Keys, the other words in the sentence like cricket, skill, he, all this gives some clue or context to the query. And the values, the actual meaning of place retrieved from the relevant words. So from attention mechanism point of view, it assigns higher weights to words like cricket, just like choosing the right books. Ignores unrelated words like he or great, just like ignoring books on theatre. By doing this, transformer ensure that the place is interpreted correctly in the context of cricket rather than acting in a play or playing an instrument or music like piano. That's all for this video, where I have covered the key concept or idea behind attention mechanism. We have covered a lot of ground through this analogy to understand 3 projection metrics Q, K and V to take the first step for learning attention mechanism. In the next video, I'll cover architectural and mathematical construction of the transformer blocks. All these Q, K, V, how they are related, and how the computation happens for weight matrices. We'll also learn about how the attention mechanism differs between encoder and decoder, and particularly we'll be focusing on decoder part of attention mechanism, like we'll be focusing on masking. So stay tuned, and if you like this video, don't forget to subscribe, press thumbs up, and share with anyone whom you think it will be helpful. Thank you so much. Let me know your comments or any feedback if you have on this video.